In today's video, I'll show you how to get up and running with Fast Agent. This is a Python library and CLI for building and interacting with LLM agents. It supports multiple providers, it has a lot of configuration options, it also supports much of the MCP spec, if not all of it, and it overall just has a really nice design and vibe to it. This video is not sponsored, I just think this tool is really cool and helpful. It's helped me out with respect to testing MCP tools, and it's also helped me out with model parallelization. So you run the same prompt across multiple models, and this thing makes it really easy to do that. I'll demonstrate that later in the video. I'll start with a quick CLI demonstration to show you what this thing is capable of. Then we'll sort of backtrack. I'll show you how to actually install this and how to run some workflows that I've set up. If you're learning AI engineering, you can go to zazencodes.com/newsletter and you can sign up for my weekly email newsletter. I'll just notify you when I upload a new video, and I explain what that video is about, include maybe some timestamps and some information about what's in that video. You can find a link in the video description. So here's the source code we're working in today for Fast Agent. Now, since I already have this installed, I can just type Fast Agent and I could pull up the help. And then this will provide us with stuff we can do. I'm going to demonstrate this go command. So I'll say go, and I'm going to pull up the help for that. And now I can pass in stuff like servers, model, and stuff like that. So if I type model, I could type, let's try GPT-5 Nano. And GPT-5 is available if you've installed Fast Agent the right way. So I'll explain that in a minute. And I could be like, who are you? Now this will make a request to OpenAI's API for GPT-5 Nano, and it'll tell me who it is. Now I'll type stop, and I can run this with a different model. So I could hit haiku. I'm just going to type haiku, and I could say, who are you? And you can see how easy it is now to start interoperating. And we can do this with all sorts of providers. If I say Fast Agent check, I'll be able to see all the models I have available. And you can see I have an API key configured for Anthropic and OpenAI, and that's how I was able to use those models. I also have this guy available, generic, and this is going to Ollama. So if I say Ollama PS, here's my Ollama processes. Nothing's running right now, but let's spawn something. So I'm going to use that as a model, and I'm going to say generic, and then I'm going to use Gemma 3, and I'm going to do the 4 billion version, and I'll say, who are you? And now, if I say Ollama PS, I can see this thing's been spun up. It's using a bunch of my GPU, and it's told me who it is. So we can speak to Gemma, local models using this. Later in the video, I'll show you running all these three models in parallel on a prompt, which is really powerful use case for this agent. Another thing we can do with this model is tap into MCP servers. I'm going to go back up to one of these commands, so GPT-5 Nano, and then I'm going to say URL and just provide the URL of an MCP server. This is something that does sequential thinking. I think it's one of the original examples that was shipped with MCP. And so once I do that, I can look for tools using this slash command, just slash tools like this. And I'm getting information on what tools the model has available. In this case, just one tool with a very verbose description, this sequential thinking, which breaks down complex problems into steps. And now I have a question queued up here from quantum mechanics. And when a clock is moving really fast, it goes slower. And when it starts to approach the speed of light, time starts to go slower. And so I'm wondering if it's half the rate, if the clock is going half as fast as a regular clock here on Earth, how fast is that clock moving? And so now it's using this tool. It's using this chain of thought, or this sequential thinking tool, to break down into 5 thoughts, and it's forcing the model to produce 5 of these intermediary thoughts, and then it outputs the answer. And this just demonstrates remote MCP use. And by the way, it's going 0.866 the speed of light. If it's going 86% the speed of light, the clock will run half as fast. The implication of this, by the way, is that say you were to travel at this speed, at 86% the speed of light for a year, and you return back to Earth, everybody else would have aged 2 years, but you would have only aged 1 year in that time. We can also use local MCP servers using NPX or UVX, Fast Agent Go model. I'll use haiku again. and we're gonna try UVX and this thing called public APIs MCP. This is an MCP server I built to fetch information about free APIs. For example, I could get a free API about image resizing. Here it's calling my server. It's like image resizing API. It's done some search over all of our free API options, and it's giving me this one, resubmit photo optimization API. And of course, I can see the tools. These are the tools I made available by appending that UVX command. What this is doing is it's providing me an interactive session with Haiku, and it gives it access to these MCP tools running locally on my computer. So it pulls this from PyPI and it runs this. And when I execute this request for image resizing, it went ahead and fetched that. It like started using this tool and running code on my computer to fetch these things. And then it returned some like synthesized response of what I should do. Nutrition fact lookup. Here I'm getting food data central and this nutrition X. And if I look at usage, I can see the total amount of context I've used, how many tool calls it's made, and other information. And we just type stop to get out of this. By the way, I'll leave a link to my public APIs MCP server down in the video description if you want to check that out. Now let me install this inside of this local folder on my computer, and then I'll show you how to build custom interactive agents. It's really easy and really powerful. Now, when I've been running fast agent like this has been using this fast agent, which I have installed here in my local bin. And how I got that was I typed pipx install fast agent MCP. That's what I ran. I ran this and it installed it in here for me. But I wouldn't recommend doing that because it's better to install it locally inside of your project. Not a problem if you install it globally or using pipx, but here's how I would set this up when you're actually using this thing in the way that I'm about to show you, where I'm going to demonstrate a basic use case, a parallel use case, and then I'll show you these workflows. And you should have UV installed, and you can say UV venv. This will create a new virtual environment right here, this venv. However, look at this, Python, I'm using Python 3.12. That's not going to let us use GPT-5 with fast agent. We need 3.13 to support GPT-5, at least at time of filming. This tripped me up for a little while, and I couldn't understand why it wasn't working for me. So what we would need to do is say UV-venv-p 3.13. Like that. And now this is going to create this 3.13 virtual environment. Great. So I've got my virtual environment, but if I say which fast agent, if I was to just type fast agent, I'm going to be spawning this version still. What I need to do is activate that virtual environment. And then when I type which fast agent, it's using the one inside of the virtual environment. So I can now just keep running my fast agent commands like this, and it will access that virtual environment here. Of course, by activating that, I'm also using the Python inside of that virtual environment. So this Python has the right dependencies, including fast agent, so that we can run this CLI command, but also we can use this as a Python library. Let me show you that now. I'm going to go into this basic folder. I don't have anything in here, and I'm going to create agent.py, and we're going to work on this. And the Python library I can access like this from MCP agent. You can see I'm getting my LSP stuff working in NeoVim. So we have access to this, and fast agent, this one right here. And then we can usually use fast and say fast agent and give it some sort of name. This one is going to be a Furgana troll. I'll explain that in a moment. Now I can say fast and use this like a decorator and pull up the agent command. Let me show you just a very basic example. We're going to set an instruction. So always respond in a mix of Furigana and English. Every other word should be Japanese. Furigana is the Japanese term for like hiragana or katakana that's not kanji. No kanjis in here are allowed. Anyway, I'm going to import async IO at this point because I need this, and I'm going to define an async function. So async def, and I'm just going to call it main. And this guy, so this decorator is acting on this function, and then we can say async with, and this is going to be fast.run as agent, and I can await something from that. and I want to start an interactive loop. So I'm going to say agent.interactive. Now this has a rich Python library, many things you can do in here. Here's just one example, and this is not going to run unless I include when to run it. So if name equals main, this will happen when we call this script. It wouldn't happen if we were to import something from this script. That's the point of the little main block. Now this will run. So I'm going to keep that open and demonstrate this. So we run one basic agent. Now down here, I just started a new pane in Tmux. So again, if I say which fast agent, this is like the wrong one. I want to use my virtual environment fast agent. Same with Python. If I look at the Python version, this thing won't have fast agent installed. I can demonstrate that. I'm going to try and run this thing with Python. No module named MCP agent. There's a few ways we can do this. Because it's a UV project, I could say UV run agent. That'll run this thing. My bad, I have a syntax error in here. I can't run that like this. I gotta say async io.run main. By the way, I'm referring to like some code over here. I'm not like just writing this off the top of my head, but I thought it would be cool to write it for you. Right, so I've updated this. This should run properly now, and I'm using UV run agent. I wanna explain how this works. When I do UV run, boom, it's working. This doesn't have access to any tools, boo, but it's gonna do some interesting response for me in Furigana. Where's the best place to visit in Tokyo? Oh, it's cheating. So it's doing the translations, but then it's translating them in English. Annoying. And also it's not even doing it because these are kanjis. So what I can do is when I run this, I could dynamically set the model at runtime. And I can instead, I'm gonna try GPT-5 mini. Give me a recipe for sweet potato muffins, which I'm making today. In that Instant Pot, there's sweet potatoes, which will become muffins somehow. Finally done. And it did what I asked it to do, and this is totally trolling me with incomprehensible output that I have no hope in following. I told you I'm going to explain UV run and how this is working with our current setup. So let me do this quickly before we return to fast agent. What this is doing is I have an agent, just this Python file, but if I look at what's in my parent folder, I have this virtual environment here. And when we do UV commands, it's finding this virtual environment and using that to do stuff. I'm going to show you how I can run this agent just with regular, like a Python command. So without having to use this kind of UV abstraction, I like abstractions, but they're a little dangerous for understanding. And I find this sort of like we should understand what's going on. So when I look at what Python version I'm using, if I just type Python, it tries to use this version here. But what I need to do is make sure that Python is using the right version for this virtual environment. And I can say source venv bin activate. Now, when I look at which Python version I'm using, it's using that one, which means what I could say is I could go to one basic, and now I can just start running these commands with plain the Python command because it's properly pointing to this, and this has the right dependency that I need. And in particular, see how it ran down there? In particular, the dependency is like this thing. It just needs to have access to this, and then it can go ahead and run this. Now, in case you didn't follow this stuff or something, I'm going to deactivate this, and I'll just use the UV way of doing things, which will be more familiar if you're just following. Yeah, this will just be more familiar for people. So we'll just say deactivate, and we're back to normal world. Next, I'm demonstrating parallelization of a single prompt. This one's super useful, and then workflows is going to give you an idea of how powerful this thing can be. I'm going to go into to parallel, and I've already got something ready here, this agent. So I've already written this, and it does model comparison. I want to compare this specific prompt across 3 different models, and I'm going to run that prompt against GPT-5 using this line here, against Sonnet, and against using Gemma 3 running locally on my computer. And I can just do that with this little piece of Python code, fast.parallel. And I've given it the name of run. And now down here, that corresponds to this run. I could say compare. I could change that so it's a little clear. That's where I'm running this this parallel command on on all 3 of these. Let me show you this. It's really cool. UV run agent. And there it goes. So it's triggered a question to GPT-5. The same question to Sonnet and to Gemma. Gemma actually responded first somehow. And look at this, it's giving me all the output summaries too. Here were the 3 questions. What year did Hokusai start and complete his 100 views of Mount Fuji collection? Gemma 3 immediately comes back and says it was 1828 to 1832, which is definitely wrong. Sonnet comes back and says 34 to 35, which kind of seems wrong as well. And then GPT says 34 to 49. And none of these used a web search. I don't have the web search configured, so that's one thing to consider. And then it does this compare fan in. This is part of the agent process and sort of wraps them in this like little response XML tag so that we can keep track of things. And it just dumps this out for me verbatim. I imagine then a lot of the output of GPT-5 might have been reasoning tokens that we weren't able to see here. In any case, this is amazingly cool, right? Because we triggered a run on our local model and to these cloud models, and I could just simply compare them like super easily. Let's extend this. Like we can easily add some stuff in here. Let's also do mini. I could also do nano. And for Gemma 3, I have a bunch available to me. Let me pick some smaller ones like DeepSeek R1 here. This one, QN 3.6 billion. I'm picking intentionally small models. I don't want to do anything to my computer. And I got a QN. So I got to update these now. Then I got to add them down here as well. This is where cursor is just so handy for like adding these things. I could be just using tab completions. So yeah, I missed that, which is funny because I do like typing. Okay, that formatted with my NeoVim auto formatting stuff. I'm just making sure all of these are accounted for. This one's in here, that one's down there, and Q1 is here. Nice. Let's do a new question though, and away we go. This is wild. So cool. We're seeing all the results that come in, right, as they become ready. And 2 more, GPT-5's coming in and Gemma 3. So this is like the tokens being output, that little counter there, but we don't get to see it streaming in. We just see it update after. Following requests were sent to the agents. What's Mozart's most celebrated pieces? And we get all the, like this is the GPT-5 response and everything. Here's the Sonnet response, agreement on this number 40 and 41. Even Q1 likes number 40. Notice how this is not an interactive thing. This just ran as a one-off. It gave me my summary and it printed a bunch of output. However, we can do all sorts of stuff in here. Like we're just printing this, but instead of doing that, I could assign this to like a result variable, and then we could start doing something with that result. So let's say we wanted to run this, and then I did want to do something with it, like ask a follow-up question. I can do this by saying await agent dot. Now I want the name of the one I want to run this on. Let's do it on Gemma 3 just for fun. Gemma 3 4 billion dot send responses into a simple output list comparing the different, and now I'll put in this result and we'll go here and save that. This should trigger this as a call to Gemma 3 4 billion to this specific agent. Notice how we're down here, Gemma 3 4 billion turn number 2. Now looking at the results, Gemma 3 4 billion, notice how we had way more input tokens for this one. That represents that additional data that we sent through it. And this was the result we got from asking that question. This is a fantastic example. Different, here's the Q1's response, DeepSeek response, Q1's response again. Probably should have used a smarter model for this one. Let's instead actually do a table. And instead of saying Gemma 3, let's use a smart model. I'll say GPT-5 mini should be more than enough for this. And I'll run this one more time. Here now we can see GPT-5 mini is taking turn number 2. And it's given me this result. And Fast Agent has also formatted this table into a nice readable format. QN is giving me wrong symphony numbers, incorrect opera titles, recommended use, do not reply. It likes itself, of course. Sonnet's pretty good, but not quite as good as GPT in the eyes of itself. That was pretty neat, don't you think? And also we can add tool calling and like tool abilities and do more stuff like this. Let me show you that. Now I'm moving on to the third and final demonstration for workflows. And to get us there, looking back at the agent we just created, one thing that was missing from here is tool calling. I'm going to show you how to do that with this Python library, build custom tool calling models. And there's many other things which we'll sort of just touch on here in this demo. If I go to workflows, I have a README file. And if you're just looking at this and downloaded this source code, this is all on GitHub. Clean up the current workflows file and build one yourself. The way you do that is you type fast agent quick start. And this is going to pull a bunch of code onto our computer, like demonstrations. By the time you install this and are running through this yourself, these might be different than what we're seeing today. I'm going to do the workflow option. And this is going to create a bunch of workflows for me. You can see them here in this workflow file. If I show my tree view, I can see all of these things were created. We're also seeing a configuration file. We haven't even talked about this yet. I'll explain how that works. And I'm going to demonstrate the one called chaining. Let me open that one up. It looks similar, right, to what we saw before. We start with this URL fetcher agent, and we have a social media agent. And they both have instructions of system prompts, how they're going to behave. And this fetch agent has access to this fetch server. I will explain that in a moment, but let me explain the chain aspect of this. Here's where we chain these two things together into a single agent called post writer. This is all pretty explanatory. Notice the order of the sequence. We're saying first fetch this URL, then call the social media thing. The implication is that we're like piping the results of the first one into the second. And instead of calling this, I'm going to do this on my own website. I've got a blog post on MCP server naming conventions. I'm going to send that off. Let me also then explain this servers part. In order to do that, we're going to have to look at this config, fast agent config. And here we have a fetch server down at the bottom here. It's an MCP server called MCP server fetch, and we're running it with UVX. And this fetch, this thing that's been configured, that's what's corresponding to this name right here, because they're in the same directory. So this chaining will look inside of this fast agent config. It'll try to find a server that's named fetch, and it will find it down here, configured in this MCP servers area. UV run workflows chaining. Missing server configuration for URL fetcher. What's happened is I don't have this fast agent config available right here in this local directory. So in order to run this, I got to go into workflow, then I can run this again. But now it's just UV run right here. I was able to find that. So it's fetching this URL. Let me zoom in on this. It's sort of chunked through it. That's kind of interesting. And now it's finishing up. It wrote it. Let's go through this whole response. It started by fetching this. The URL fetcher ran this, and it sort of continued fetching. So somehow this URL fetcher got called multiple times, but at a different start index to kind of return the data in chunks, I guess. So the URL fetcher itself actually summarized the key points. Why did it do that? Given a URL, provide a complete and comprehensive summary. So it fetched my page and then it provided that summary. This is still output from above. And then the social media guy says, learn how to graph perfect packages, blah, blah, blah. Now let me show you how we can use this configuration. We can set something called default model. And here I'm going to say, let's say try OpenAI.GPT-5 Nano. I'm going to save that. And now when I run this, I'll run the exact same thing again. We're going to see here, GPT-5 Nano is running this thing. So that's what that configuration does. I can also add more MCP servers in here. Let me add one for a random number generator. This is my server that I'm fetching down here. The command is UVX. Here's the source code. I'll link to this down in the video description. And to set it up, I type UVX and then random number MCP. So that's what I'm just going to paste into here. Okay, whoa, no. Oh man, like that. And now this guy, I can give this tool, I can provide this tool inside of wherever I want to use it. Copy this. Let's try and demonstrate this with the human input agent. This is something Fast Agent does that allows us to bring human into the loop. It's really cool. But I'm going to add an additional thing where we'll also give it access to this random number generator server. In this case, I'm not going to do this command. I'm going to say, ask the user what they want. And this should trigger the human input tool. I'll explain that. I'm also going to comment this line out. And very simply, this is the line here that does the human input. This is just fast.agent with an instruction. And the server it has access to is my random number generator. And then the human input is true, which this command here should cause a prompt to ask me a question. I can run this with UV run human input. And yeah, servers. Try that again. Now it's issued this request to GPT-5 Nano. I've said, ask the user what they want. And because GPT-5 Nano, oh, that didn't work. Okay, it didn't work. Let's try it again. This might not always work. It says this usually causes the LLM. Here we go. This worked this time. What is going on here is we've said, ask the user what they want, which and GPT-5 Nano has also been informed that it has access to a tool called human input, and it should call that when we need more information. And clearly, ask the user what they want should trigger that. And so it's done that, and it's given me like, what would you want help with today? And that's what we've provided in the result. So this is a request for a tool call from GPT-5 Nano, which got picked up by FastAgent and presented to the user. Like the application presented it to me. Now I can provide another input here. And I want to simulate an encounter between a warlock and a vampire. And I'm hoping the model will use my random number generator tool to roll some dice as part of this encounter. This is done, but unfortunately it didn't do it. It just used one tool call, was for the human input. It didn't actually use my server, so I'm not exactly demonstrating what I wanted to do here. One thing I could try is just using a different agent. Take this and comment that out. I'm going to try using Haiku. It's a better tool calling model sometimes. Clearly this would work better to demonstrate this in an interactive type loop. Okay, I'm going to create a new file. I'll call it dnd encounter.py. Open this up, and this one I want to create into an AI agent. Okay, I'm not even going to give this an instruction. It'll have this server. I don't need that. Interactive. Let's clear this. UV run dnd encounter. So it's spawned up, and I can see my tools. So I have all these tools. This pretty much is the point, right? These are all the tools that I configured. It has access to these things. And the reason is because I've gone ahead and said servers equals random number generator, this line right here. Now it should be able to simulate my encounter, and hopefully it uses these. So it started, it's rolling a D20. The vampire rolls, oh, it's going step by step, and it keeps calling these. The warlock's attack hits. The eldritch beach deals 4 damage. So it keeps rolling my my random dice here and getting different results, and using that, it kind of like simulates this whole encounter for me. A location is a dark Gothic castle. Warlock's first turn launched an eldritch blast, successfully hit, dealt 4 damage points. Vampire's counterattack, used claw attack, successfully hit, dealt 5 points of damage. That's all I have for this video, but when I run FastAgent Quick Start, you can see this workflow example. That is all of these workflows which I generated here. For example, we could talk about the router agent, which is relatively simple and does a bunch of interesting stuff and then pulls it together using this fast router. So the idea is we're not using like a sequential order anymore. It's going to kind of like the agent is going to kind of figure out which one to use at the right time. It's a really powerful agentic pattern, really basic one as well. But there's other interesting stuff in here like orchestrator as well. Anyway, I need to stop. This is something for the next video. If you're interested in seeing this, leave me a comment and let me know. I can make it for you guys. And also, if I've already created it, I'll link it right here at the end of this one. And that does indeed bring us to the end of the video. If you enjoyed this and if you learned some stuff, please give me a like. That helps support me here on YouTube. And you can subscribe if you want to keep learning AI engineering with me here on Zaz and Codes. Thank you for watching, and namaste.